Hi, this is Victor and welcome back to my math tutoring channel. In this video, we'll try to solve this indefinite integral. If you look at the degree of the numerator, it's equal to 3 and the degree of the denominator is equal to 3. And usually we said when the degree of the numerator is greater than the degree of the denominator, we do the long division. Here I'm telling you, even if it is the same degree, it's easier to do the long division. So let's start by doing that. So I have x to the power of 3 plus 10x to the power of 2 plus 2x plus 9 divided by x to the power of 3 minus x to the power of 2 plus x minus 1. So here I want to multiply x3 here by something to have this x3, and that something will become 1. So 1 times x3 is x to the power of 3, 1 times minus x2 is minus x2, and 1 times x is x, and then 1 times minus 1 is minus 1, and then I subtract everything. So I have this x to the power of 3 minus this x to the power of 3. This is 0, and then I have 10x squared minus x squared. So minus minus become plus, and here I have 11x squared, and then 2x minus x is x. 9 minus minus 1 is plus 10. And now the degree of the rest is less than the degree of the quotient, so I will stop here. So my division, I can write it as 1 plus 11x squared plus x plus 10 divided by x to the power of 3 minus x to the power of 2 plus x minus 1. Yeah? So that integral, I can do it as integral of this dx. So I can do it like integral of 1 times dx, which is dx, plus the integral of 11x squared plus x plus 10 divided by x to the power of 3 minus x to the power of 2 plus x minus 1 dx. That first integral here, it's easy. The integral of dx is equal to x plus c. So let's circle that because I will use it at the end, and I will focus on doing that integral for now. So let's do that integral. So it is integral of 11x squared plus x plus 10 divided by x to the power of 3 minus x to the power of 2 plus x minus 1 dx. Here I have the degree of the numerator less than the degree of the denominator. I have to think about decomposition into partial fraction, but to do that I need to have multiplication like in the denominator. So let's see if I can do something in the denominator here. I can see that here this x3 minus x squared, I have x squared in common, so I can put x, I can factor out x squared, so my integral become 11x squared plus x plus 10 divided by x squared, and here I will have x minus 1 plus x minus 1. That's very good. Now I can factor out x minus 1. So my integral become 11x squared plus x plus 10 divided by x minus 1. Factor it out. Here I will have x squared, and that plus I will put it here, and then I have to multiply x minus 1 by something to have the x minus 1, and that something would become 1. Perfect. Now I have multiplication in my denominator, so I can apply decomposition into partial fraction. So let's take 11x squared plus x plus 10 divided by x minus 1 times x squared plus 1. Here it is equal, because here the degree of that part of the multiplication is degree of 1, so I can put a divided by x minus 1, and the degree is 2, so I can put bx plus c divided by x squared plus 1. I have a lot of video that explained the decomposition into partial fraction, and if you look them up at my channel, Vic the Math Tutor, one word, you will find them. I have a lot, and you will understand how come I came with bx plus c and the a. Yeah. Now let's do common denominator on the right hand side of this equality. So I have 11x squared plus x plus 10 divided by x minus 1, x squared plus 1 equal, the common denominator is x minus 1 times x squared plus 1, and here I have to multiply the a that is here with x squared minus 1, so a times x squared plus 1 I mean, and the bx plus c I have to multiply it by x minus 1, so I have plus bx plus c multiplied by x minus 1. And now, because I have the same denominator on the right hand side and the left hand side of my equality, I can get rid of the denominator, and let us work on the right hand side. So I can multiply a by x squared plus 1, so it becomes ax squared plus a, plus I will multiply bx plus c by x minus 1, so it becomes bx squared minus bx plus cx minus c. Actually, let's move it a little bit so I can put everything on the same line. Minus c. So this is 11x squared plus x plus 10. So here I can find, I have a and b that has a coefficient of x squared, so I can factor it out. So it becomes a plus b multiplied by x squared. And here I have cx and bx. I will start with the c minus b multiplied by x. Actually, multiplied by x, and I have plus a minus c here. So if I look at the left hand side, the coefficient of x squared is 11 and the coefficient of x squared is a plus b, so I can conclude that a plus b is equal to 11. Here the coefficient of x is c minus b, and here the coefficient of x is 1, and the one that does not have x, I have a minus c, and the one that does not have x on the left hand side is a 10. Okay, so from the first one I can conclude that b is equal 11 minus a. So if I replace b by its value on the second one, which is 11 minus a, I would have c minus, I open my parentheses, 11 minus a is equal to 1. So this is my b here, c minus b. So I would have here, I would have c minus 11 plus a is equal to 1. So minus 11 would go to the other side. I will have c is equal, c is equal 11 plus 1 is 12 minus a. So if I replace c by its value here, I would have a minus 12 minus a equal to 10. So I would have a minus 12 plus a equal to 10. So here I can say 2a equal 10 plus 12. So 2a is equal to 22. Divide here by 2, and I divide here by 2. So my a is equal to 11. Now I can replace my a equal to 11 in this formula here. So c equal 12 minus 11. So my c is equal to 1. And then I will replace a here by 11. So my b is equal 11 minus 11 is equal to 0. So my b is equal to 0. So if I go back to to this here, the integral, that integral, I can write it as, I replace a and b and c by its value. So let's write it down here. So the integral of 11x squared plus x plus 10 divided by x to the power of 3 minus x to the power of 2 plus x minus 1 is equal, we said a divided by x minus 1, and we know that a is equal to 11. So it is equal 11, and here we said x minus 1. X minus 1, this is the integral, and I open the parentheses, plus the b is equal to 0 and the c is equal 1. So I have bx plus c. So 0 times x, 0, and the c is equal to 1. We said 1 over x plus 1 square. Was it plus 1? Yeah, x squared plus 1. It was x squared plus 1. And all that dx. So that integral, I can write it 11 integral of 1 over x minus 1 dx plus integral of 1 divided by x squared plus 1 dx. And I have to remember that here I have integral of dx, which is, let's put it integral of dx. So my final answer is equal integral of dx plus 11 integral of 1 over x minus 1 dx plus integral of 1 divided by x squared plus 1 dx. So that integral of dx is equal to x plus 11 ln of x minus 1. Because I can take u equal x minus 1, so du equal dx, it's equal dx, and I have 1 over u, which is ln of u, and I replace u by its value, which is x minus 1. And then here, this is a formula, a trigonometric formula. The formula of 1 over x2 plus 1 is equal arctan x plus c. So I can replace that by arctan x plus c. So I have plus arc tangent of x, and all that is plus c. And that would be my final answer for this exercise. Let's fix this a little bit. This is 11. If you like my video, please subscribe to my channel. That would help me tremendously. And if you really like it, I would appreciate if you push the like button. Thank you for listening.